Hi everyone. So I'm aware that in my previous videos my voice hasn't been particularly easy to hear. I do have a very bad microphone because it's an embedded webcam microphone, and I do intend on replacing it. I just haven't got around to doing that yet. So in today's video we're going to look at respawning, and that was a feature that wasn't particularly easy in the previous version of the system. It's now possible to reassign a pawn to a connection, or more accurately, a controller, so now that functionality does exist. On top of that, to implement respawning and the features required by it, I added support for setting or sending messages from a spawning object to the spawned object, and created a very tight relationship there that you can employ to basically do things with logic bricks with added instances in a way that wasn't possible in plain logic bricks. So before we get into that, there have been quite a lot of changes to the code base, mainly just in the main loop files. The code is a lot cleaner now, and it makes it a lot easier to develop with. Most of it's now stuck into classes rather than exposed methods, and there is a dedicated message class which is dealing with all of the various messages that we receive, and they're all prefixed. So now a lot of the messages in the network system are prefixed, which means that they belong to specific objects. They always have a context. The only message that I send that doesn't have any context is the controller request message, which is asking the entire scene if it can provide a pawn for a network controller. So let's actually look at what we're doing. In this game, you've already seen this example. There are these two spawn points which are physically just visual proxies only. They have no meaning in the game. On layer 2 there is these two meshes, the red and the green, which correspond to teams, and we actually set those by on the last layer running a replace mesh. Now there are two networks, two groups of net mode states, and we have the server state here and the client state here. I'm trying to move towards a naming convention where any sensors that or controllers or any logic bricks which belong to a server state have an S prefix, and any logic which belongs to a client state has a C prefix. But I haven't quite finished doing that yet. So because the spawning all happens on the server, the most changes, and really the only changes, have happened on the server. So if we go to look at the server states, this top right state, state 4, basically does what we've always seen with the server, which is to send, when we receive the RPC call from the client, is to basically apply the position from the properties that we got via an RPC call. Now state 3 is a state that actually sets the teams, and previously that was set from a property. But now this is set from something else, and all it does is sorry, that was wrong. These messages originally didn't have a prefix, and they just set the teams, and they only worked when you spawned a network object. And they just set the team property, which, when that is changed, triggers the replace mesh on the last layer. And if you recall, when this property is changed, it is actually replicated using the network system to the client, so the client will also get this property, even though it's on a different computer. So if we go back to the state, we receive a message with a special prefix, and that's one new change, and that's to do with the coupling relationship between spawned and spawning objects. There's also a new system for attacking. So when you attack a player, what the client does is it sends a request to start an attack by RPC start attack, and that RPC call has no arguments. So if you look, no arguments are selected, it just sends a notification to the server. The server then adds, using edit object, a projectile, and it adds it with some linear velocity. So this projectile itself is here, and this projectile does some very simple things. Whenever it collides with something, it just kills itself, and it runs a basic Python controller that makes sure it always aligns to its velocity, so it looks like it's falling in the direction it's moving. So none of this is network-specific code. It also has a property isProjectile, which indicates to the game that this is a projectile. So if any collision sensors detect a projectile, they can react appropriately. So the real logic lies on Suzanne. Now in Suzanne, whenever we are collided with on the server by a projectile, we add a state, which is the respawn state. And in the respawn state, which is this state here, which is state 19, we deal with the respawning. And this is run on the server, but is only added when we're hit by a projectile. And what we do is we first run this controller here, and you'll see that the F is checked. And this is important because this means that this controller is executed before any other controllers on this object. And what this does is it asks by a message the network system to reassign the pawn, a new pawn instance for the current controller. And it gets the current controller from the object that sends this message. So this has to be sent from the current pawn, which in this case is an instance of Suzanne. And when it gets this message, it will respawn a new copy of Suzanne, because that's what I've typed in here at the end, and it will then delete or unregister the previous version. Now, as soon as this message is sent, we then run these later controllers, and their job for these controllers is to actually set the team of the newly spawned Suzanne, because if we're spawning a new copy of Suzanne, it won't have a team yet, and because we're respawning, it makes sense to set the same team that we were on beforehand. So what this does is it sends a message on init, and then it sets the team green or red accordingly. Now, the important note about this on init message is when it's sent. Essentially, on init is a relationship between the spawned object and the object that does the spawning. Whenever you assign or reassign a pawn using the controller assign or controller reassign, and just to remind you, controller assign is actually implemented on the dispatcher, where we set the current pawn for a new connection. Whenever you send a message with controller assign or controller reassign, this on init message can be sent. And what it does is it means that for the network object that was spawned by this message, it'll send this message with the same prefix. So if we go to Suzanne and look in the first layer of the server states, you'll see that we're receiving an on init message, and that is, as you can see, that is sent either by the dispatcher when it spawns a new Suzanne, or by Suzanne itself, an old Suzanne, in the respawn state. So the grand sum of this means that whenever you die, you can be respawned, and it'll recreate a new instance of Suzanne. It'll move Suzanne to the appropriate team, because that's what Suzanne does when you set her team. So you can see here when the team's changed, we either go to red or go to green, and it'll set the colour as we need it. So now respawning is supported, and it also improves some of the reliability of the code. Now there are a few caveats to the game system now. If I run a server, run a client, occasionally, I think it's usually the first client, the client doesn't really behave itself, and the reason for that is it didn't assign a team, because basically there's a bug in some code that I don't want to fix yet. So that does happen, and we're mainly in a testing phase rather than in a release phase. So I'm happy to have that in my code. And you'll also notice that on this client, which is this, you actually can't see. If I show you the client, the position is a little bit jittery. And the reason for that is, in fact you can't see it yet. If I show you another client, the other one didn't register as disconnected yet. You'll see that on the right-hand client, which is the one that's seeing the left-hand side is the one I'm controlling at the moment, the position is a little bit jumpy, and the reason for that is that the position extrapolation is not enabled correctly. It is enabled, but it doesn't use the correct timing information. I will fix that in future. It just requires me to make some further changes. But anyway, that's all the changes for now, and I'll keep you posted.